Right, okay, so carrying on with locating error intervals. So I'm looking at question 6. I don't really like question 6 to be honest, but we'll talk about it anyway. Um, so it says that the student writes that there's an asymptote within the interval. Um, so even though there's a change of sign, f of x has got no roots in the interval. Well, that's what I was on about before. I was saying f has to be continuous. So I'm going to draw this graph. So it's 1 over x. Add, oh, weird. Add 2. Okay, so what happens there? 1 over x, like that. And then add 2 means the graph moves up 2. So the asymptote then becomes here. So it's the line. What's that? Y equals 2. And the graph looks like the... Oh, weird. That weren't my fault. That was the paper. But this is what the graph looks like that. Right. Okay. So this is earlier I was talking about when you've got a change of sign, f still needs to be continuous because look at this discontinuity here, and by discontinuity I mean a point in the graph where it jumps. So it jumps from being one value up to another without joining. So look, f of x is negative there, and f of x is positive there, but there's no root in the middle. Okay, this is just your axis as an asymptote, isn't it? That's why I'm saying f of x has to be continuous. Now, this question, I say it isn't very good because it says by means of a sketch or otherwise explain why the student's incorrect. Well, I feel like he's right, except that -1 comes out here. And I know that because you can sub in and work out what -1 is. So 1 over -1 is -1, plus 2 is 1. So that means it will be up here, so somewhere between 0 and 2. So there is actually a root in the interval, but at the very beginning I said that we use this technique to work out roots to equations that we can't solve. Well, we can solve this one that easy. 1 over x add 2 equals, well, it's 0, isn't it? So 1 over x equals -2. So x equals -half. So that's the answer to that. That's the easiest way to do it. But equally, you could say that, in an error interval from -1 to, something just less than 0, so like -0.1 or something, then there would be a change of sign and it is continuous, so then there would be a root. But I don't really like them saying that between about -1 and 1 there's 1, just because there is that discontinuity in that interval. It's not my business to criticise questions like, but I just don't like it. Okay, right, number 8 though. I do like number 8, and I like number 8 because again, you have to draw a graph. Yes. Okay, you have to draw the graph, and it's really quite important on this one. Now, sketch the graph of e to the -x. So what's that look like? So e to the x looks like that and goes through 1. E to the -x is just flipped, reflected in the y-axis, I should say. So it looks like that, exponential decay, and it goes through 1. Okay, there we go. And then x squared, right? I'm just, let me say, put that really steep there, really, going towards the x-axis there. X squared, yeah, it is, yeah. Looks like this, and I've got something important to say here. Ah, my pen slipped then. Okay, now, what if I do this so that these crossed, these two? What if I do that shallower and that steeper so that they crossed? And then you think, oh, hang on, is the 2 points where they cross? Do they cross here and then somewhere over there? Well, no, I don't, because e to the x is much, much steeper than x squared. Now, I've said before to my class, like, that x squared is steeper than x cubed steeper than x squared, x to the power 4 steeper than x cubed. So that's how it goes, okay? So, an e to the x is steeper than any of them. So this is steeper than that. That means that one goes off that way, that one goes up much steeper. So there's no way that they meet again. So that means the only time e to the -x and x squared meet is there. So there's one solution to that. E to the x equals x squared. There's one solution. In other words, there's only one solution to this, which is f of x. So there's only one root to f of x equals 0. And that's that there. Okay. So that's my explanation there about why it's only got one root. I haven't written it. But what I just said is what it is. Right, now show that it's got a root between 0.7 and 0.71. Well, this is just what we've been doing on our calculator. So let's work out f of 0.7 and let's work out f of 0.71. Okay. So f of 0.7 is, go ahead, right, e to the minus 0.7, take away 0. Oh no, come on. Take away 0. Sorry about that. 0.7 squared equals, that's a positive number. Okay, 6. I'm going to write 6 just because it's in round. And put a little 1 in there. Yes, negative number. Minus 0.012. Okay, change of sign in the interval f continuous in the interval, what is it, 0.7, 0.71. I've gone off the screen, have I? Yeah, big time. So that means that 0.7 is less than alpha is less than 0.71. Okay, nice one.